AEEWI Western India chapter to Western chapter for this opportunity. I hope by the end of it, your participants will have some information about the subject that we are talking about.
Yes.
So if everything is set, shall we begin?
Sure.
I'll just share my screen. Give me a minute.
Yeah.
Okay.
Yes.
Is my screen visible?
Yes, it is
Okay.
visible.
Thank you so much. So good afternoon, all of you, all the participants. My name is Shamkant Mirashi. Ma'am has already given a very elaborated introduction. So I will not spend much of a time, but let me start here. So we'll be talking about low energy air conditioning solutions, where we will essentially talk about what is the technologies, what is the need in the first place. We'll subsequently get into various technologies, and then of course we will also look at some of the applications where we actually foresee. I mean, so we are not talking about our technology for sake of it. We'll also see that what are the various areas where it will be applicable. Because if my understanding is correct, most of you in the audience, you are practicing energy auditors, or you are considering yourself for energy efficiency to your end clients. And I'm sure your focus will be more toward understanding where these technologies or where these solution that we'll be talking about are relevant. So let's begin. Based on the standard protocol, if somebody want to stop me in between and ask a question, that's most welcome. Otherwise, we can always take it at the end of the seminar. Let's go by the standard protocol. So welcome you all once again. Uh, as I said, I understand that most of you will be practicing energy auditors, and when you create a report, I'm sure you will be agree to this number, especially for buildings. And today, there are a lot of industries, including the data centers, pharma, food process, so on and so forth. So there are these industries, and most of our commercial and industrial building today, where air conditioning is one of the major loads. As you must have heard during my introduction, I also consult on ISO 52001, which is the energy management standard. Last year, I did an implementation for one manufacturing company in the vicinity of Pune, and where we identified ECUs, the significant energy users. In spite of the fact that it's a manufacturing unit, one of their prominent ECU was air conditioning, right? So that's a scenario today. Uh, apart from the fact that they are a major guzzler, we are now talking about how they are deploying those chemicals which are not ozone friendly. Their potential for adding to ozone depletion and so on and so forth. So all these things are being highlighted for quite some time. That how HVAC are, I always say that HVAC is one bottleneck when we talk about going net zero or making our buildings green and so on and so forth. So that's how this subject was relevant to us, and with whatever small little understanding I have on energy efficiency and the kind of training I have acquired, somewhere we felt that this is the area that we must be focusing on, and then if we can do some wonder here, uh, I'm sure. So let's say, for example, today if one of my building is consuming 50-60% power, and if we can do some substantial saving there, it's going to be a measurable savings in the overall consumption. So this is how it has become a point of concern and area of our working. uh, COVID came in, and then there are a lot of new challenges which the buildings have started seeing, because post COVID now people are talking about more oxygen has to be come into place, more fresh air has to be allowed, especially those building where we have a lot of people who are working, operating out of the building, because some of the standards which are laid down by either ISHRE, Indian Society, or ASHRE, or other global organizations who were working in this subject, they laid down these kind of standards post pandemic. And most of these standards are talking about that the air conditioning building need to have more ventilation, more fresh air, more amount of oxygen has to be ensured across the building so that the IQ can be maintained and so on and so forth. Now, for the kind of HVAC system that we have deployed at this while, and if we all of a sudden start talking about taking more fresh air inside the building, it's going to be lead to another set of problems. So, that's a very cliche management sentence which says that when there is a challenge, of course, it comes with some kind of opportunity. So that's exactly what we are also trying to look at. All these problems which are being laid down are the opportunities for bringing in more innovation and trying to see that on one side we want to be comfortable, but on the other side, how we can do it at a little more energy efficiency way. So that's something we'll be discussing in the coming slides. Uh, Cooling, of course, I definitely know that almost all of you in the audience will have a basic understanding what is the cooling is all about. We talk about comfort cooling, process cooling, and so on and so forth. So let's not invest much of time here. In case of comfort cooling, it is believed that when we and there are of course studies which are available that unless we keep our people comfortable in their working place, their productivity we will not get as much productivity from those individuals as we can get them when they are made to work in a comfortable place. And then of course today we are talking about multiple applications where process requires that the temperature and humidity to be maintained. It could be modern industries like data center, or even it could be the age-old industries like pharma and food processing and so on and so forth. So it is the cooling is no more a comfort of the people requirement, but it is also getting into process. And as I promised in subsequent slide, we will also look at some of those process areas or industrial areas where cooling is required, and how we can intervene and reduce the cooling load on those particular areas. So this is something that we understand, and we all as an engineer, we know for sure that today if somebody throws a challenge that what, I have this kind of building or I have this kind of shade and I want to maintain temperature and humidity to a particular level, these are the two main technologies that comes to our mind, right? I'm sure everybody will be aware about what is air cooling. It is a technology where we mix air and water together. There are various nomenclatures to it. Somebody call it evaporative cooler, air washer, you name, right? So all of you who are coming from different industry verticals will be aware about different nomenclature to it. But what we are essentially using is a thermodynamic phenomena where air and water get mixed. They come in contact. So when the hot air comes in contact with the water, it transfers its heat to the water gets evaporated, and we get a cold air. So when we try and explain to a fresh client, we say that. So what happens in evaporative cooling? We have hot and dry at the inlet. It goes through the evaporative system, and the outlet we get cold but wet. So initially I had a dry air, I get a cold air, but which has got a lot of moisture into it. So it is of course a very fundamental and very entry level cooling technology when especially we are cooling large areas when temperature and humidity is not a major concern. And we generally want to see that, okay, if outside is 40-45 degree like today, inside it should be 30 degree plus minus, so that people who are working will be a little comfortable. So that's one technology. As I said, one of the limitation of this technology is that it gives you air which is high in humidity, and it's 100% dependent on ambient condition. So today, when my temperatures are hot and dry, I'll get a comfortable temperature out of this. But come monsoon, they will hardly perform anything. Or if I install these systems in Nagpur or Delhi or Pune, let's say for example, where I belong, then we get a very cold air coming out of these machines. But if I install these machines in the evaporative cooling systems in Mumbai, we may not get as much comfort. The reason is there is a lot of humidity in the air in Mumbai and around the area. So although this is a low energy kind of a cooling technology, the acceptance may become a little challenge, right? So that's one technology comes to our mind when we talk about cooling a place. The second technology is, of course, most of you probably already enjoying the cold air coming from your air conditions. So that's another technology, which is by now it's almost 120-year-old as a technology. First implemented by Dr. Wills Carrier, And you will be surprised, some of you, the young engineers, if you are in audience, you'll surprised to know the first time air conditioning system was installed not for cooling of the space, but to control the humidity. And you see, thermodynamically, the principle behind air conditioning system, what we call vapor compression systems, the basic principle of the system is to control moisture and temperature. It gets, it's a byproduct. So that's a kind of technology that we have, and we are using almost across our requirements. But the first and foremost problem that we foresee with these HVAC systems is their power consumption. Is there the chemicals that they are deploying, and so on and so forth. There are multiple things which must have been discussed in various platforms. So as of today, these are the two prominent methods of cooling that comes to our mind. And by the end of this presentation, we will see that is there any third alternative, right? So that's something, let me keep some kind of a secret, and which will get revealed as we progress through the presentation. So these are two technologies which are here because the evaporative cooling is known to India, especially for last probably couple of 100 years, where we are cooling a large building like Taj Mahal and Gol Gumbaj by using evaporative cooling as a principle, where we have another 100-year-old technology. Both are surviving, both are here, and both are being deployed in various projects. So which essentially means they have some kind of advantages with them. But as we spoke 5 minutes back, both these technology have certain amount of limitations, certain amount of issue challenges. And when we are moving forward, we are trying to see that can we build a third alternative which will pick up a good part of these technologies, combine them together, and we will have a third alternative. That's how this question mark at the bottom of this slide. Now, when we are looking at an alternative, we actually go back to very basic. And again, I appeal some of the young engineers, if you recollect your thermodynamics, the definition of air conditioning by books is it is a technology which simultaneously, right? It's very important. It simultaneously controls temperature and humidity. Where in reality, if we see that when I'm employing, when I installed a 1 ton, 2 ton air conditioning in my house, you will realize that as the temperature drops, the humidity also starts going down. You will see that there is a good quantity of water being collected at the outside, right? Uh, if any one of you have a asthma patient in your house, you will know for sure that when you go for a regular checkup, doctor advise these patients not to sleep in the air conditioning room. The reason is our body requires certain amount of humidity for its good functioning. And if it is not maintained, which is when you are conditioning a room with air conditioning, your body start losing its moisture because the air conditioning is taking away all the moisture, right? Okay, the long story short, so although we are saying that air conditioning is by definition need to control temperature and humidity simultaneously, it is not doing that, right? And that's one limitation. And as I said in the beginning, whenever there is a limitation, you always look at an opportunity and try and see that how we can correct it by having innovation, right? Uh, Now, this thought of ours got more concrete, more concrete support when we came across this. Some of you must have seen it or must have followed it. Also, there was a global level competition which was been organized by India between 2018 and 22. It was awarded by Mr. Branson at the end. So I have given the website also for those who are enthusiastic. You can probably go and have a look. So of course, there were three winners were declared, and the competition was to identify technology which will give a cooling at optimum possible energy consumption, right? That's what the competition was. These were the 8 finalists, and you will surprised to know out of these 8, 6 companies have demonstrated a hybrid technology. That means they have not gone ahead only with refrigeration, only with evaporative cooling, or only any other XYZ technology. They demonstrated that unless there are two different technologies which are known to us, they combine, we probably may not able to have the so-called energy efficiency or the so-called low energy conditioning. So this is very interesting. So when I look at this in one of my recent presentation at ISHRE, I say that when I looked at the website, it gives me confidence that I'm working in a correct domain, because there are 6 global companies feel that this is the way forward. For those who definitely want to have a look at, please visit his website and you will get to read more about it. So this is another question that we are asking people today, that when you are saying that you want to save energy, you have to relook at and understand whether you want to do a ventilation or you want to do air conditioning, right? Because ventilation has its own advantage, has its own way of designing systems, and so is air conditioning. So this is another way, because you see, it's not always like, I cannot say that yesterday till yesterday I was using diesel fired car and tomorrow I go for EV. I cannot drive both the cars in the same way. When I adopt for a EV, electrical vehicle will have its own protocols, the way to you drive, the way you put it for charging, and so on and so forth. It cannot be compared. So any new technology will definitely demand it's the way we are operating. So today I'm saying that when I want to have my building to be a little more clean or green or net zero, I cannot just go and say that, you know what, I need an air conditioning system which will consume very less power and I still want to maintain 24. It may not be possible. So we'll have to bifurcate the loads and see that which area is relevant to what technology, right? So that's another approach that we are proposing. So let's touch base upon what are the alternate cooling technologies that are available. So let us start with air washer or air cooling system, because that's one fundamental thing. And as I said, as we know, this is something that we know as a technology for the last couple of 100 years. In this industrial avatar, we know that today when I'm setting up a evaporative cooling system, what I get is a it's an AHU kind of a boxes, and you have a cooling media on which we spray water, right? So the hot and dry air will come in, will hit this pad, with this hit this cooling media, and then we get a 42-degree air. So these are the lesions, okay, when we are traveling through. So that's a CFM. This is dry bulb. This is wet bulb. RH, relative humidity, and so on and so forth. So this is my incoming air, which is ambient air, hot and dry. It gets filtered. It comes to this cooling media. It loses its heat to the water, and I get a temperature which is definitely comfortable. But this is always about the wet bulb, because again, those who remember their thermodynamics, adiabatic cooling or evaporative cooling is limited by wet bulb. The approach is wet bulb. So we cannot cool that air below ambient wet bulb, and we get a substantial cold air. But the only limitation here is the dry air is now absolutely wet. You have almost 86% of humidity. And if you see the grams of water, it's almost 17 grams, right? This is what evaporative cooling does. Now, we already highlighted this as a limitation. How can we improve? So the next version, the next technology, or the next improvisation that we have done in conventional air cooling is we have added one more cooling stage, right? This is a cooling stage by virtue of an air-to-air heat exchanger. Somebody want to know, probably we can take it offline. Uh, but what we are doing, so we are enhancing the performance of the same air cooling system by adding one more cooling stage, right? So today, if somebody asks us for a ventilation system, we say that yes, we can offer you a cooling system, which will have two cooling stages. The second stage will continue to be the same cooling media. What we have in addition is an air-to-air heat exchanger, which is homegrown, which is has got a proprietary features to it. But now we see what enhancement we have done is, if you remember these number, we are able to cool this 42-degree air down to something like 25-degree. Now the same air, same given input condition, we can cool it down to 21-degree odd, say 22-degree for all practical purpose. We have achieved a delta T between incoming and outgoing of almost 20-degree. We have now cooled the air below ambient wet bulb. This was ambient wet bulb, 23.8. We are able to cool this air now below ambient wet bulb. If you see the moisture in earlier slide, you saw that the moisture was very high, 17 grams of moisture per kg. Now it is only 14.4, 14.5 for all practical purpose. So we get a cold air. It is saturated, but it is saturated at lower moisture content. So I had hot and dry air at the input. I got a air which is cold and comparatively dry. When I say comparatively, comparative to is the immediate competitor, which is a conventional air cooling system. right? So this is how we are enhancing the performance of conventional air cooling systems, conventional air washers, evaporative, whatever the nomenclature that you are comfortable with. So by intervening into it, by adopting an additional technology, which will get seamlessly integrated. Whereas when I'm using word integration, it essentially means that we can offer a new product which will have both these stages sitting inside a regular HU cabinet, or if somebody has got an existing air washer system working, we can go and retrofit, we can go and add onto the existing systems, right? So both possibilities. We typically use this nomenclature called green field and brown field, right? So we have opportunity of both. We can have greenfield opportunities as well as brownfield opportunity. What is that we are bringing in the table? We are bringing more low, I mean, we are bringing lower temperature. We are bringing in air which is at comparatively lower moisture. It is saturated. It is below wet bulb. Now, this lower temperature alone is going to be beneficial? Yes and no, both, because I will have a better comfort inside the space. Anybody can agree to it. If you look at it from design perspective, and any HVAC consultant here in the audience will agree to it, when I'm designing a system, if I have to cool a factory premise and somebody say that, you know what, I've got 100, I got X amount of heat load. So we as a consultant, what we do this, we understand that what is the heat which is sitting inside that place. Heat which is by virtue of the building gain, by virtue of people, by virtue of, whatever the heat process inside. So we understand what is, how much cooling we have to arrive. So we say that if I have a, X square meter kind of a factory premise, we sit down and do the heat load calculation and say that, okay, there's a 1 lakh square feet ka factory shade. It has got 100 ton equivalent heat to be removed. Now, when we say that if I have evaporative cooling, which is giving me 26 degree ka air, and now I have another technology which is giving air at 22 degree, and I have to remove same amount of heat load from the space, uh, those who are comfortable with the HVAC design, they will realize that with evaporative cooling, I would have required 1 lakh CFM, 1 lakh cubic feet per minute. That's the amount of air that would have required, because I was offering the air at 26 degree. Now, since I'm getting air at 22 degree, lower temperature, I can pick up the same heat at maybe 70,000 CFM, cubic feet per minute. So I can reduce the capacities of the ventilation systems on day one. So instead of having a 1 lakh CFM ka blower, I can do the same job at 70,000 CFM ka blower. We cut down. It could be 30, 40 kilowatt avoided on day one, right? So that's kind of benefit that we can offer here. Okay, if I go to psychrometry, if this is how my conventional air washer looks, this is an additional cooling that we are, this is additional cooling that we are offering, right? And if you see, those who are comfortable with psychrometry will be agree that this is a process which is that constant, humidity quantity. I mean, the gram per kg. Excuse me. So this is called sensible cooling process, because we have neither added any moisture or removed any moisture. So this is that additional cooling that we are bringing in, and because of which the final result, you will see that there is a gap, right? It's a technology which is so what we are talking about is a technology which removes. Now another thing, if you see, this is enthalpy, kilojoules per kg. We have removed enthalpy from the air, right? Generally, enthalpy removal is considered with air conditioning, with so much of tonnage and so much of GPM of water and so on and so forth. We are removing enthalpy of the air by doing what? By spraying a small quantity of water, by having a small quantity of pump, and there is a air which is passing through the heat exchanger. Now, if one puts this number in perspective, if you see that from 70 kilojoules to 58 kilojoules, this enthalpy removal, it will translate into X amount of tonnage. And if you see that tonnage, how we have achieved, and if you see the electrical load to do this, the translation looks something like 200 watts per ton or 300 watts per ton. As against air conditioning, we all know that we talk about 1000 watts per ton or 1200 watts per ton. Well, with this technology, we can remove the enthalpy, we can cool the air, with low power penalty as low as 200 watts to 300 watts, right? So here we are talking about technology which can pre-cool the air at very low power penalty. The first application essentially in evaporative cooling or air cooling technologies. We are saying that the same technology will be applicable when we talk about air conditioning, right? You see, when we talk about air conditioning, essentially we talk about a sensible cooling and latent cooling. When we throw this air on the chill water coil, we drop the temperature and then we remove the moisture, right? That's how the typical curve is. I have it in subsequent slide. Today, the same refrigeration coil is removing temperature as well as removing moisture, and that's where those who are well versed with the HVAC will be aware that the fresh air loads are almost 3 times higher than the recirculation, and that's another set of problem we foresee. So this could be a typical scenario. I have a same fresh air. We discuss applications like pharma to chemical to food, where these kind of requirements are there, where you take the fresh air, you cool it down by refrigeration coil, and you offer it in the space. Even your standard commercial building, they have these systems called TFA, treated fresh air systems or fresh air systems. They take fresh air, they put it on the coil, and they take the air at very low temperature, right? And these are the loads which are almost 3 times than a regular air conditioning. We are saying that now, since we have a technology which can pre-cool that air at very low power penalty, we intervene there as well. And we say that we'll cool that air from 42 degree to 30 degree. So the coil is no more exposed to 42 degree, but the coil is exposed to only 30 degree. So coil will send a signal to the chiller saying that, you know what, I'm getting a air which is pre-cooled. I don't need so much of refrigeration flow now. I'll require uh, inappropriate language. I know what you know what I mean. So the coil is going to demand less chilled water. Why? Because now it is exposed with the air which is pre-cooled. It is no more exposed to the ambient air of 42, 43 degree, but is exposed only 30 degree or so. And the coil is going to demand. So I'll probably, oh, I think I missed here. So we have seen and we have deployed the systems where, the power consumption is reduced by almost 30%. We have system installed here in Pune. We were lucky enough to be involved at the design stage with a consultant. The original design of the system was almost 300 ton. This is installed sometime in 2019-20. By our intervention and thanks to the consultant that he was open enough to look at these suggestions, the 300-ton original load, the system is delivered at 200 ton. So 100 ton avoided on day one. And it's working from, as I said, sometime in 1920 to all the way today. 100 tons of load avoided, which results in at least 120 to 130 kilowatt avoided every hour. And I'm talking about last 5 years, right? So probably one can do the arithmetic and arrive at how many gigajoules of gigawatts of energy that we have saved. But that's kind of intervention is possible, and we have designed and delivered this consistent. We have done projects all over India. Almost we are done in Delhi, Pune, Mumbai, Hyderabad, so on and so forth. There is in Nagpur, we have a project which is designed by a very senior consultant from Thane. It is for a school in Nagpur. And we had done a couple of projects in Middle East, including Dubai and Oman and so on and so forth. So we are talking about our intervention in air conditioning technology leading into 30% energy saving. And that's what. So, all the things that we spoke initially, we are hybridizing, we are combining two technologies. We are looking at evaporative cooling in best possible way and refrigeration cooling. Because see, what happens here is when the air is coming here, the sensible load is taken care by one technology, and latent load or moisture removal is taken care by different technology. So both these technology are working at their best, and the resultant is one get 30% energy saving. I'm sorry, there was one slide which I think I missed out, where we actually talk about a number that, without intervention, the power consumption would have been 60 kilowatt. By intervention, it's coming to something like 40 kilowatt. We had done the enthalpy calculation. My mistake, I think I missed out on the slide. It was getting a little longish, so I was a little concerned. Anyway, Today we are designing these kind of HUs and delivering where they are taking enough amount of pressure, they are taking return air, and there are smart controls which are monitoring what is happening in ambient, what is happening in the space, and accordingly they are deciding whether one should take only fresh air, should take return air, should take a combination, and so on and so forth. Right? So systems are going smart enough thanks to the modern controls that the AHU itself will able to decide that, let's say if I'm in Pune and if I have 24 by 7 working office, when Pune ambient goes to 20 degree, there's no reason that I should be running my chiller, right? I should take the air, filter it appropriately, and just put it in the space. If I have air which is at, let's say, 35 40 degree, the humidity is just about 20%, which is very common in Pune. That means I can get 22-degree at supply. Why should I run my refrigeration? I can take that air, cool it by my two-stage of cooling, offer it in the space. Come monsoon, humidity goes high. I can reduce the fresh air quantity. I can increase the return quantity, and so on and so forth. I mean, all this can be done without any manual intervention, right? So that's a modern cooling technologies that we will be talking about. We are saying that divide and rule sounds coming from our history books, but that's not it is. We are saying that divide the loads and treat them separately, and then host of the advantages that I spoke for last couple of minutes, right? So that's what we are bringing in table. So I'm sure, as I said initially, most of you engineers from the industry or those who are doing audits, you'll be interested to know what are the applications that we are talking about. So let's talk about applications which are not necessarily comfort of the people, but as we said initially, is there any process which demands control temperature humidity? Lot many times you will see that the control panel rooms inside a process plant, they are being used air conditioning. These are IC standard, and we proudly say that almost anywhere in India, almost anywhere, probably we can sit down, do the numbering, and we can come back openly that okay, may not be relevant, but almost anywhere in India, we can comply to this IC standard and yet offer a very energy efficient cooling system for control room panels. Not only control room, we also talking about cooling of HTLT panel. We have done control panel cooling for a pipe company in Jalgaon. I'm just referring in those areas. We have done a control panel room for a captive power plant, 8 megawatt near Purley, right? And these are all 4, 5, 6-year-old plants working still fine. Again, as I said, we can comply to this IEC standard and yet cool these kind of application. These are the modern building problems where you have UPSs, battery. They also need to be maintained at temperature humidity. They can be done just by two-stage, indirect, direct, or they can be done by hybrid systems, right? Those who are frequently working with auto industries, this is one area. Test bed, they take 100% fresh air because they want to maintain the they cannot recirculate the air because there is so much of CO2 and CO in the air. They cannot take it back. They want to, and yet they want to maintain the engine at a constant temperature and humidity to test its performance. So this could be ideal area where we can talk about savings. Paint booth, another, especially the class A auto manufacturers, like the car manufacturers and even two-wheeler manufacturers, they deployed large size ASUs, air supply units. Uh, they have filtration, then they have those spray systems, heating system, chill water coil, and then there are flames and whatnot. It's very complex systems. We say that if we can reduce the temperature, most of the problem gets solved. Now, especially in that belt of Rajasthan and North, and even this area, even we go to south like Chennai and around, we can reduce the temperature. That itself will address so many problems. And as I said initially, this can be retrofitted. So if you have an existing ASU, we can go and retrofit without any how you say without walking into the ASU, to put it very short. This is one area which every energy auditor in the audience will agree that this is one of the most energy guzzler. And if you refer to Bureau of Energy Efficiency input, they say that every 4-degree drop in the inlet can improve the efficiency of air compressor by 1%. We cannot do it by air cooling because so much of moisture will go inside the compressor. We cannot do it by air conditioning because whatever we save at compressor, all will be consumed at the air conditioning. We can do it better. because we are sensibly cooling the air, very low power penalty, no moisture added, and we can offer a cooled air. We'll be deploying our first systems for one of the category A auto manufacturer near Mumbai. Once the results are here, of course, we'll be happy to share. Pharma, I mean, entire healthcare for that matter, right? Not only hospitals, but pharma manufacturing, taste, you name. So the entire healthcare sector, they use a lot of fresh air, which can be pre-cooled by our intervention, again, in a greenfield mode or brownfield mode, and we can demonstrate. Food, we had done an installation in Hyderabad a couple of years back. These are those ready-to-eat popcorn. You just put them in a cooker and don't put the lid and they start popping up. They had a problem because they couldn't manufacture a particular flavor because again when you have a flavor, see in Indian food you have either a lot of masala or a lot of chini sugar, so you cannot recirculate the air. It goes back, it gets stuck into the coil. So they have to have once through systems. Once through systems, they have their own set of problems, hot air coming in, power consumption, not able to maintain. We have delivered that. We had delivered it for another chemical process also in Hyderabad where they had a same problem. And yes, so we have no case study as yet, but we are in serious talk with the data center because the same data center we are talking to them for some other set of solution. Today, data centers can be identified on a thermal map. If you take a global thermal map, you can identify data center. They are throwing so much of heat. Most of the heat is coming because of the air conditioning, and we can definitely be assistance to them. And last but not the least is all your building. So building again, it can be for comfort cooling. It can be non-critical areas like your the entries and the lobbies and kitchens and I mean you name. So all these areas can be done. Plus we can look at the fresh air. Plus we can look at the non-critical areas. Plus we can look at the electrical panel room and other stuff that we spoke about. So if green buildings bottleneck is air conditioning, we'll be happy to assist those designers, right? By virtue of our solutions. Okay. So this is the one set of solution that we are talking about. But air conditioning is not only. I mean, we generally say that the air conditioning is similar to power generation. So you have power generated, like cooling generated, cooling transmitted, and cooling being used. So all this while we look at the solution which are on the user side. Let us look at what happens at the generation side, which is the chiller side, right? I'll take 5 more minutes and then we can, yeah, and then we can go ahead with the questionnaire. So we are aware that there are two types of chillers, air cooled and water cooled, based on the heat rejection. We are proposing a third alternative, which is again evaporatively cooled air cooled condenser, right? Again, water cooled, air cooled, both have their advantages. That's how they're surviving so long. But both of them have their some limitations, some issues, some challenge. Like water cooled, there's a too much of hassle to install and then too much of hassle to operate. If any one of you in the audience is operating cooling tower, you'll be aware, right? Maintaining them, then adding chemicals and so on and so forth. There are a whole lot of issues and things. And against that, how much saving we get, that could still question mark. Other side, air cooled condensers are easy to install, easy to maintain, but they lose their efficiency when the ambient temperature goes up. We are saying that let's combine the good part of both this technology and combining together. Uh, Again, where our thought is coming from. So this is coming directly from Train, one of the largest chiller manufacturer. Train says that their 200-ton chiller, I've highlighted an example, will deliver 200 tons of cooling, right? Roughly about 200. When the ambient, the condenser entering temperature, that is ambient outside temperature, is 85 degree Fahrenheit. 85 degrees, about 29, somewhere between 29 to 30. So when my ambient is 29-30, my 200-ton chiller will deliver 200, right? And not we are saying, Train saying so. When the ambient temperature starts going up, the same 200-ton will deliver only 170 ton. Almost 20%, not 20%, maybe about 15-18% decrease in the capacities, right? And at the same time, the power consumption from 216 kilowatt, it goes to 276 kilowatt, almost 30% going up, right? So on one side, capacity goes down. On the other side, the power consumption goes up, right? This is a limitation of cooling down? The answer is we say that we encapsulate the complete chiller by cooling media. We allow water to trickle on the cooling media. Air travel through this cooling media. It offers cold air to the condenser, and condenser is back to its design condition. So, say for example, if this is my ambient condition, 115 is roughly about 42, 43 degree, which is for people like Nagpur and all, they are well versed with it. But even if I say that I'm 105, right, and my condition as my chiller capacity has gone down on one side, my power consumption goes down. If I can from here, if I can take it all the way till here, one can see that what is the amount of saving we can achieve, right? By now, we must have done close to 18, 20,000 tons worth of a chiller in various projects. Like this one project, there are multiple chillers put together, almost 1,200 ton. This is one project. This is in Bhiwadi, uh, outskirts of NCR. These are 300, 350 ton 4 chillers we recently did last year. These are few chillers in Pune. This is some VRV system in Mumbai and so on and so forth. Here again, this is greenfield. So the OE, the chiller manufacturing team, they installed, commissioned the chiller, they walked out. Then our team went, did the encapsulation, and they came out. So it's a greenfield project. While these are retrofitting, these are all 7, 8 year old systems. They were losing their efficiency, and client evaluated this before investing in a new chiller. I mean, best techno-commercial thing. So this is what we do, and by now the kind of result that we have collected, we talk about the peak summer saving could be 25 to 30%. Annual average will be about 10 to 18, 15 to 18%, right? It consumes less water as compared to what the water consumed in cooling tower, because in cooling tower is not only evaporation, there are also like pilferages and so on and so forth. So all that is being avoided. Water is handled within very small space. So not too much of maintenance is required. No chemical dosing, no nothing. Very low maintenance. As I said sometime back, the data center slide when I showed, we discussed, we are doing 22 chiller. Okay, not 22 in one go. So 20 odd chillers for data center company in Mumbai. My team is right now there. Our team is there right now doing the installation. And so they did almost 2 chillers from us. They installed it 1 year back. Almost through a year, they saw the savings. And once they got convinced, they said, okay, we want to do the rest of the chiller. So that's kind of thing. So this is something energy saving done at the generation side of refrigeration cycle. Initially, we saw the the saving coming at the user side. So that's quick about me. I represent companies, both are sister concern, and I'm a external resource or a consultant with both these companies. We talk about design, execution, product development, and so on and so forth. We always think that Airmaster is a portfolio company with CII, Confederation of Indian Industry. CII takes us along whenever they go and talk about energy efficiency. Renotech manufacture these heat exchanger in-house. These are type tested by Emerson Lab and so on and so forth. So both these companies with their pluses, we are going out in the market and trying to assist our client. Thank you so much. Any question? Please feel free to ask.
Excellent presentation, Mr. Mirashi.
Thank you, ma'am.
And it is very relevant now while we are in May, and everyone is worried about the electricity bills and also how to make the cooling effective. And
Absolutely.
We have a lot of questions today. Yeah, so let's take it one by one. So the first question is in just one sec. Yeah, Mr. Avinash Shinde is asking, in AHU system, why three-way walls is necessary?
Three-way wall is not necessary when we have said that on particular slide. So what we are saying is, let's say, for example, the kind of hybrid AHUs that we are talking about today, we will pre-cool the air, we reduce the load on the coil, and coil may send a signal to the chiller saying that it doesn't require so much of water flow. This can be done either by two-way or three-way valve. So whenever the load goes down, it sends a signal to this valve. The valve will rotate and the flow to the chill water coil will be reduced. So much of water will not come. And if it starts accumulating in the evaporator, I'm sure we all understand that the load on the chiller will go in an offline mode, and that's where we'll get additional saving. So two-way, three-way, it's up to the designer. But yes, having a two-way valve with this kind of hybrid AHU will definitely have advantage. We'll have more saving.
I hope that answers your question. Again, the second question is from Mr. Avinash, and he says nowadays ECE fans, not ECE, it should be EC fans are used in AHU.
Plus, yeah.
Instead of high capacity fan. Is it useful for energy saving application, and what will be the impact on airflow?
If we are talking about an EC, yes, they definitely offer some. They offer saving, of course. Only thing, whatever small little experience that we have, they may or may not able to handle the higher pressure. So in industrial environment, we have seen that there are certain cases where the fans were replaced with EC, but after their deployment, the air distribution become a little challenge. Today, there is a next version called EC Plus. There is one or two companies who are talking about it. They also claim a lot of energy saving. We haven't used much. We have used in one or two projects. But yes, in the industry, we are coming across case studies where people are saying, especially the auto industry, they are saying they are deploying their maybe paintwood ASUs and all high pressure, and they are getting better results. At the same time, they are getting energy saving. So to answer your question, yes, they offer you saving. Definitely.
And another question is from Mr. Uday Kulkarni. He says, thanks for your informative presentation. Please advise approximate simple payback period for IDEC, retrofitting existing unit, Pune weather, tariff and cost considerations.
Wow, that's a tough question on one basis. It requires some amount of.
It can be taken later.
Yeah, if you can please share my contact details, we'll be happy to assist. Or probably if you can share.
Definitely, yes, we will be sharing.
But any corporate is comfortable, anything below 3 years, and I can say that yes, it can be well within 3 years.
Great. So, Mr. Krunal Kavre, he is asking, if we do indirect cooling only, then what will be the air parameters? I mean, how much degree lower than WBT?
Generally, if I say that if I'm in Pune or Hyderabad, Nagpur kind of a condition, we can cool the air at least by 10 degree in peak summer. Okay. So I can say that 8 to 10 degree drop is possible against ambient. So ambient is 40, we can offer 30 degree air as an example.
I hope that answers your question, Krunal. Yeah. And another question is from Mr. Tejveer. In once through air conditioning, having SHF less than 0.5, what are the best possible energy efficiency solutions?
SHF less than 0.5 is very rare to find. We actually have to see case to case basis. But I mean, again, very difficult unless we'll do the number crunching somewhere on the Excel sheet. It will be very difficult. But why you will have SHF less than 0.5? At least at this point in time, I don't come across any application where it will be so low.
Yeah. So, Mr. Tejveer, you can again discuss with Mr. Mirashi. We'll be sharing his contact details here.
Please.
And another question is from Itela. Now, there are two parts of the question. One part is for me, I suppose, and second part is for you. So, Mr. Itela, you have asked that can we have training sessions offered by AEE so as to update skills. So, AEE, like if you are a member of AEE, you can appear for exam certifications like Certified Energy Manager, Certified Energy Auditor, CMVP, and also other sustainability certifications are available like even for HVAC, building consultant, there are many certifications are available, right? So for that, you have to be member of AEEWI. Also, AEEWI is offering various webinar series and also giving the credits for which are being used for certification renewals and to get the certifications. So you can get in touch with me so that I can guide you for becoming the member of AEEWI. And regarding this webinar series, this is a free for all, and definitely I hope it is helpful for updating your skills also. So be in touch and keep attending these sessions so that you can learn more and more. And now the second part of the question is for Mr. Mirashi. So will the evaporative cooling can integrated with district cooling system?
Yes, of course. Yes, of course. So evaporative cooling not standalone. The hybrid AHU, that slide we discussed,
Yeah.
where we are taking ambient air whenever it is favorable, and we take a return air whenever the ambient is not favorable. So those kind of hybrid configuration can be definitely used along with district cooling. Why not?
Then again, Vinash is asking to share the PPT. So what we do is generally we share the recording on our YouTube channel, AEEWI Western India. And so this recording will also be available there, maybe by tomorrow. So you can have a, again, go through it from YouTube. And now another question is from Mr. Vadi Venkatesh. How much will be the kW per TR of air cooler chiller if it is pre-cooled? And again, there are 2-3 questions. So let's take one by one. Yes, Mr. Mirashi, how much will be the kW per TR of air cooler chiller if it is pre-cooled?
Right. So as I mentioned during my presentation, we have a number which are coming from the field. We have users. We have confirmed that during peak summer they got a saving of almost 20-25% against their current listing, and the annual average is about 15 to 18%. So let's say, for example, if your chiller was consuming 1,000 unit per day, and this is the actual number I'm referring to for a small chiller we did in Mumbai. They come back and they say that now the chiller is consuming anywhere between 840 to 850 kilowatts. I mean, kWh essentially in the same day. So roughly about 15% in Mumbai. But yeah, the number, if I had to say, roughly about 25% in peak summer, 15 to 18% annual average.
So another question is, can we use pre-cooling for package or split and Windows AC?
Of course, Windows is something there's more of a commercial reason than a technical reason. Technically, it will work in for any air-cooled chiller, air-cooled condenser. That means by now we have done it for package, VRV and chillers. Anything below that, it becomes commercially little unviable. Unless somebody there says that I have got a 200 ODUs of a small thing, then we can definitely look at, right? It's only a commercial viability point of view. But yes, it can be done.
And again, he's asking, how precise is EC fan speed control compared to VFD control?
In our view, it is the same. It is the same. One can achieve similar savings with a plug fan and VFD as compared to EC fans. Some of this technology, their initial costs are so high because since we design and sell AHUs, we come across these kind of things that the cost comparison is there's a drastic difference as compared to the saving. So I think one can achieve similar results with direct driven fan, any configuration, and EC fan. One can achieve similar results.
Yeah. Thank you, Mr. Mirashi. And again, Mr. Saeed Mohammad Faik Raza is asking, dear sir, kindly highlight at minimum water quality required to prevent scaling on the condenser of chiller or clogging on cooling pad. How often we need to maintain this system to run at its design intent?
So we recommend potable water, which is essentially means 300 ppm and below. That should be the level of water that we get. Potable, which is drinkable water. If the water quality is maintained, the scaling will be minimum. And if one has to maintain, it could be because you see it is open in the air. So the health of this system will depend on water quality as well as air quality. If I have too dusty environment, then it may get choked very frequently. If it is not, and if I'm talking about a very tall tower and the systems are sitting on top of it, the cleaning may be in couple of couple of quarters. In fact, we say that the non-tangible benefit of these pre-cooling systems is often the coil get choked, the condenser coil get choked because they are exposed to the direct environment. Instead of that, with our system now they get packed up, right? They are being encapsulated, so they are not exposed to the air directly. So the coil maintenance, it's probably every month or something, which can be extended to probably a couple of quarters. So it will depend on water and air quality, but yes, somebody can look at a couple of quarters down the line for cleaning it.
I hope that answers your question, Mr. Sai. Mr. Dhananjay Gande has congratulated you for excellent presentation. And
thank you so much, sir.
It is projected very deep knowledge of the subject and fluent manner in which the topic was subjected. His question is, please elaborate to what scale have low energy AC systems penetrated HVAC market?
I'm sorry, I didn't get that.
Please elaborate.
What scale have low energy system penetrated market? Yeah. So the scale is very low. We are speaking, I mean, we are lucky enough to have your blessing for last 10 years. But what we used to speak 10 years and today, there is a vast difference. We have quite a few references, not only in India, even abroad. We have delivered almost all those applications that we have mentioned, almost all, not all of them. Because no offense meant, but as a senior energy auditor, you are also aware that we are not very progressive. Progressive may not be correct, but we are a society where any new thing, we always want to ask this question, ki pehle kahan kiya hai? And that's a question still being asked to us. But we were lucky enough to work with people like Honeywell and Siemens in this meantime. They say that if not their client, they can take the they can take this plunge, and they went ahead and installed the systems, and they are delivering the savings. So to answer the question, we were absolutely at a struggling stage 10 years back when we started talking. Today we have quite a few references. Just to give a reference between you, I mean, in Pune we are delivering 4 lakh CFM for Cummins for their Kothur plant, and this is something you will be able to relate, sitting in the same town. So that's the kind of references that now we are generating.
Yeah. So next question is from Mr. Venkatesh. So how pre-cooling works for Middle East considering the limited availability of water?
It will work fantastic. Limited availability of water is there. I will not deny that. But having said that, if you go around, I mean, whatever small little experience I have in Dubai and Oman, you go to even small hotel, they are running evaporative cooling. That means they have water available, right? So it's not that water is not available. Point number one. Point number two, these are modern societies, so they probably have better water treatment system. So if I have a commercial building, I have 500 people working there, and if I have a STP, and if I'm getting a water out of STP, that water can be used on these cooling systems, right? In fact, we say that you are consuming so much of energy in STP. By saving energy on chiller, you get, at least some amount of that energy get replenished, or you get some recovered. So definitely, water is available. It's only that how effectively we use it.
So I hope that answers your question, Mr. Venkatesh. And the question is from Mr. Nageshwara KH. So in the hybrid AHU, the enthalpy of air is constant during coil cooling. The enthalpy supposed to reduce. Please elaborate on this.
Enthalpy of the air is constant during coil cooling? No, sir. In fact, we arrive at tonnage calculation based on enthalpy difference. When we put a condition of air on the coil and air off the coil, the difference is in enthalpy. That enthalpy difference could be by virtue of temperature drop, humidity drop, or both. So the enthalpy is not constant. Definitely, it's supposed to reduce because you are taking away enthalpy. and that what leads to the so much of kilojoules of energy or BT of energy or tonnage of energy. So it is not constant. The enthalpy is constant only in evaporative cooling. It is got constant enthalpy because you are converting sensible load to latent load. Uh, Otherwise, across all other cooling and heating process, the enthalpy shifts.
Yeah. So, Mr. Nageshwar, I hope that clears your doubt. And yes, of course, I have shared my contact details, and Mr. Avinash shall be sharing the AEEWI membership and exam details uh, to you. And I have already shared Mr. Shamkant Mirashi's contact number also. Now, again, Ms. Venkatesh has a question that do we have warranties issues on new installations if we go for pre-cooling on new assets? Any suppliers providing by design with pre-cooling option?
Uh, Warranty issues won't be there because we are not obviously. So our solutions are non-invasive. So we are not walking into any warranty areas, right? We say that when we are installing system, we only take a mechanical support of the frame of the chiller. Barring that, we have no intervention. Point number one. Point number two, to answer your next part of the question, uh, one of the photograph that I showed, it is there are two of them, in fact, three of them, where it is installed in the fresh installation because it was specified in the BOQ in the tender, right? Today OEs like Kirloskar and Blue Star and Train and one or two more multinational manufacturers, they are offering this system as a part of their package. So it is almost in thing. But and if required, we can always sit down with your OE and clear their doubts about any warranty validation or something. We can always do that.
I think that was satisfying answer. And again, Mr. Nageshwara has a question like, what is the effect of moisture in the air on the air-cooled condenser due to pre-cooling? And what is the water consumption for pre-cooling? What is ROI for pre-cooling setup?
Right. So if you go reverse, sir, the ROI for a standard commercial building, if you are paying like 10, 12 rupees a power, your ROI will not exceed 2 years. And of course, if you are running your chillers for more than 8 hours or 10 hours a day, then it will be not more than 2 years. Water consumption will vary every hour, depend on the ambient. We say that it will be roughly about 8 to 10 liter LPH per ton for a given chiller. So 10 liters, say maximum per 1 ton of chiller. So if I had 250 ton, of course, we'll talk about 2,500 liters of water consumed. And moisture doesn't settle. So, so we spoke about one technology. There is another technology which is making entry in the Indian market where they spray water directly on the coil. Now, that's something which is harmful because coil directly getting exposed to the water settles on the coil, it evaporates there, it leaves all the salt and so on and so forth. So that's harmful. What we are doing, as you correctly said, is a moist air which is just passing through the chiller, and it is so hot. It hardly makes any difference. And as it is, most of our chillers survive through monsoon, right? Anywhere in India, there is a monsoon through which they survive. So they definitely survive through this as well. Uh, the biggest advantage with our biggest differentiator with us is we are not spraying water on the coil directly, which is not something which is good for the health of the chillers.
So that answers your question, Mr. Nageshwar. And so Mr. Gande is going to invite you for his lecture series,
Honor, sir.
EKLS series. Yeah,
Honor, sir. We'll be happy.
that's nice. And thank you so much. All the questions have been answered, and I hope all the attendees have been benefited through this very insightful session. And Mr. Mirashi, I hope you enjoyed the interactions with
Certainly.
the participants.
Participants,
And,
yes.
thank you so much once again for being on this webinar series. Thank you, attendees, and all those who have questions regarding memberships and AEE examinations. can contact me on the mobile number. I have already shared that in the chat box, and also my email ID is shared. For recordings, you may visit our YouTube channel, AEEWI Western India. Thank you so much.
Thank you, ma'am. Thank you once again for this opportunity, and thank you all the attendants for their interest and staying for so long. Looking forward for more interaction. Thank you.
Thank you. Bye.
Signing off. Thank you.